Hello everyone, welcome to these comprehensive tutorials on DevOps project, specifically setting up an Azure App Service staging slot with Azure DevOps pipelines for automated build and deployment. My name is Zoran and I am Senior Cloud Solution Architect. This project showcases how DevOps practices streamline development lifecycle, enabling efficient code management, automated testing, and seamless deployment. Within this DevOps framework, I develop a real-world e-commerce web application designed as an online bookstore. The bookstore app allows the customer to search, add books to their cart, and complete purchases while providing an administrative interface for managing the book inventory, all integrated with Azure Cosmos DB for scalable data storage. Throughout this video, I will guide you step by step from preparing the local environment to deploying and expanding app, demonstrating how DevOps enhances these solutions. Let me be clear, this tutorial is not to show you how to create online bookstore app, but to show you how to use DevOps to automate entire this process. Let's dive into preparation phase. In the first step, I prepare the local environment by organizing the folders and setting up the DevOps organization Texas Bookstore org and Project Bookstore app in DevOps portal to manage under a unified DevOps umbrella. Then I generated a new Git repository for the project in Azure DevOps and synchronized it with my local machine using VS Code and using clone repository feature from the DevOps portal to clone this structure into VS Code on my local computer as the destination. I created two subfolders inside the root, front-end to store client-side files like HTML pages, and backend for server-side code such as server.js. This separation enhances maintainability and scalability, which is crucial for an e-commerce app. This organized structure ensures that when we build the app.zip artifact in the pipeline, all necessary files are correctly included for staging slot deployment, setting a solid foundation for our DevOps workflow. Once the folders are set up, we are ready to create the necessary files and services. This project requires a database and a web app, so I installed the Cosmos DB database and the web app service with a staging slot in the Azure portal. First, I created a new Cosmos DB account, naming it Texas Book DB. I selected the NoSQL API for document storage and configured the database bookdb with a container books using /id as the partition key. Then, I created an Azure App Service for the Bookstore app, naming it Bookstore Test Zoran, selecting the Node.js 22.x runtime for compatibility, and defining specific environment variables. I enabled deployment slots by adding a staging slot, which allows us to deploy changes to staging for testing without affecting production, ensuring smooth manual approval in the pipeline before swapping. As you can see, I have already created several key files in VS Code, like package.json in the root folder, defining the app name Bookstore app, listing dependencies like Express and at Azure/Cosmos, and setting scripts for start. Node backend/server.js. Also, I created .env in the RUT for local environment variables, adding Cosmos_endpoint and Cosmos_key from the Azure portal. Then I created index.html in the frontend folder for the customer interface, including search, cart, and checkout features with fetch calls to backend routes. Finally, I created server.js in the backend folder. File plays a critical role as the main backend script that manages the server logic. This file is the heart of the backend, connecting the frontend to Cosmos DB and enabling the DevOps workflow for my project. Initially, I also created an Azure Pipelines.yml file in the root folder to set up a basic pipeline, defining a simple build and deploy process to get started with Azure DevOps. Later, I enhanced this file by adding a multi-stage pipeline configuration, including the build stage for artifact creation, deploy staging for staging slot deployment, approve and swap for manual approval, and production swap for slot swapping to support a more robust DevOps workflow. These files form the backbone of my app, ready for local testing and DevOps integration. Let me briefly explain the initial YALM file. This file automates the build process, starting with a trigger that activates the pipeline on every push to the main branch, ensuring continuous integration for our e-commerce application. It uses an Ubuntu latest virtual machine for a stable build environment, ideal for Node.js apps. The pipeline then installs Node.js version 22.x with the node tool task, setting up the runtime needed for smooth operation. Next, the npm install script installs all dependencies from package.json, preparing the app for packaging. The archive files task packages the entire project from the source directory into a zip file named app.zip, including front-end and back-end folders ready for deployment. Finally, the publish build artifacts task publishes this zip as a drop artifact, making it available for later deployment stages in our DevOps workflow. After creating the Azure pipelines.yml, I added and committed files to the repository with synchronized changes. In the next step, in DevOps portal, I created a new pipeline using Azure Repos Git. Selecting the Bookstore app repository and choosing the Azure pipelines.yml file from the main branch, which I successfully uploaded in previously step. This set up the pipeline for initial testing without staging node involvement, allowing automated builds. After the pipeline was initially created, it was time to enhance our YAML file to automate the procedure with an approval process and swap staging to production. Let me briefly explain this updated YALM file. This file automates a multi-stage process, starting with a trigger that activates on every push to the main branch. It uses a Windows latest virtual machine for a stable build environment, supporting Node.js with enhanced reliability. I define variables like node version set to 22.x for the latest LTS, app name as Bookstore Test Soren, resource group as Texas Bookorg, and Azure subscription as Azure Connection for centralized configuration. The pipeline is divided into stages. The build stage installs node.js, runs npm install, archives the working directory into app.zip without the root folder, and publishes it as a drop artifact. The deploy staging stage downloads the artifact, lists files with PowerShell for debugging, and deploys to the staging slot. The approve and swap stage adds manual approval with a 1-day timeout, notifying me to check the staging slot. Finally, the production swap stage swaps the staging slot to production seamlessly. This setup ensures a robust zero downtime deployment process for our Bookstore app. I used git add azure pipelines.yml and git commit-m to commit, then pushed for synchronization, ensuring the pipeline runs with the new workflow. Process automatically starts upon pushing changes. Once it reaches the point where approval for swapping to the production environment is required, I approved this, and after all deployment finished, I tested the web app at bookstore testzoran.azurewebsites.net by adding a book and verifying it syncs to Cosmos DB, demonstrating the successful deployment and functionality in production. As you can see, new book is added successfully in Cosmos DB. In the second part of our DevOps journey with the Bookstore app, I decided to expand the e-commerce application by separating the administrative function to create a dedicated admin interface for managing the book inventory, distinct from the customer-facing production pages. This expansion allows administrators to add and delete books efficiently, while customers continue using the existing search, cart, and checkout features seamlessly. First, in VS Code, I updated the project by creating a new file, admin admin.html in the front-end folder. This file includes a user-friendly interface with forms to add new books and delete existing ones, using fetch requests to interact with the backend. To support this, I modified server.js in the backend folder, adding a new admin route to serve the admin.html page, and implementing a delete route to handle book deletions from Cosmos DB, complete with error handling and logging for tracking. These changes ensure the admin functionality is fully integrated with our existing Cosmos DB infrastructure. After committed these updates, this triggered the Azure DevOps pipeline automatically, showcasing how DevOps streamlines the expansion process. The pipeline executed the build stage, creating the app.zip artifact, and deployed it to the staging slot for testing. After deploying, staging slot is finished. Then visited the staging slot URL, bookstore-tests-staging.azurewebsites.net/admin, to verify the new admin page. I added a book, confirming the changes work with staging-specific Cosmos variables set in the slot configuration. This isolated testing ensured no impact on the live production environment. After validating the functionality, I approved the swap in the pipeline, allowing a seamless transition to production without downtime. Once the deployment process finished, I checked the production URL, bookstore-tests-azurewebsites.net, to verifying the expanded app works perfectly. As you can see in production slot, no more admin task to add page on index.html, but users can continue search, select, and make purchase. This process demonstrates how DevOps, with its staging slot setup and automated pipelines, makes expanding the Bookstore app easy, secure, and efficient. Thank you for watching this tutorial. We covered everything from local preparation to production deployment, showcasing our robust e-commerce solution developed with DevOps. See you in next video.